All right, we're going to go over this Unit 2 Day 4 warm-up. This is a good warm-up for the Unit 2A quiz. This includes the categorical portion of the Unit 2A quiz. I've put box plots will also be on there, that one quantitative. Just talking about, you want to watch what's happening here with this problem on number 1. See, these fruits are different size, and so it kind of looks like there's more cherries less cherries because there's only 4, they're smaller, and it looks like there's more bananas, but there's still only 4 of each of those. Plus, is there 4 cherries or 8 cherries? I don't know. Okay, now, this is, once again, one of your, the discussions about if there is an association between two variables and using the information in our two-way table. Okay, so first, what we've got, the two variables that we have are body image and gender. And so the question is asking you to determine if gender and body image are independent variables. So again, if they're independent, there's no association between them, nothing going on, no relationship. The fact that you are one thing does not change the rate if they are independent. Independent, 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 when the fact that you are one thing does not change the rate. So those percentages have to be exactly the same or within 1 percentage point. So now, first thing I also notice is I have a different number of females in this sample than males. So in order to remedy that and to be able to compare similar make it similar totals, I'm going to have to get it proportionate and a percentile, because then that's like what you would have out of 100. So therefore, since I think explanatory variable is probably that, or is that gender, because I think gender is going to have an impact on what the body image is, or that's what we're checking to see. So then I'm going to use the 760 and the 440 as the denominators. And if I was doing marginal, then I would use the 1200 as the marginal denominators. So conditional probability is going to be these female about right, overweight, and underweight, and the male about right, overweight. So the conditional would be those values. The marginal would be this one with the totals, and that would give me the overall about right, overall overweight, and overall 110. I'm sorry, underweight. All right, so when I went ahead and I showed this chart here, I think I put that one in there, and so I did the fractions, see, so that I did the fraction and the decimals, and I did them to the tenths place so that I can compare and see if they're within within 1 percentage point of each other. So because I only have 2 things I'm comparing, I actually can compare females to males. But remember that we want to if there's more categories in this explanatory variable, so if there were, then we would want to compare it to the total, the marginal. Okay, so here we go. I see differences happening. So therefore, I think the fact that you are one gender has an impact on the rate at which you think of yourself as about right, overweight, or underweight. So there we go. Therefore, you can say a couple things. Gender and body image are associated, have an association, or gender and body image are not independent of each other. Elaborate, because the fact that you are male or female affects the rate at which what you think about your body being about right, overweight, or underweight. Now we're going to give statistical evidence, and we want to give statistical evidence in each of these categories. So what's happening here in the about right? Well, I can see females think of themselves as about right at a higher rate than males. And then I would put the numbers, 73.7% compared to 47%. In the overweight category, females think they are overweight at a higher rate than males. 21.4% of females think they're overweight. 16.4% of males think they are overweight. And then in this category here, in the underweight, it's definitely higher for males thinking that they are underweight. So for the males, 16.6% think they are underweight compared to only 4.9% for the females. So that's what exactly I wrote. Those statements are what I wrote, and then I supported with the statistical evidence of that. And so that is how you do a complete write-up for your discussion about the association or relationship between two variables, and that's how you support it with statistical evidence. All right. Next, we have a mosaic plot. So we're going to take a look at this. I see that we have got type of vehicle. That looks like one of the variables. And then where the location or the origin of the cars. So type of car, a vehicle, SUV, sedan, those things, and country of origin the cars came from. So which vehicle type has the most subjects in that? Well, because of this wider amount, I can see sedans definitely have the widest bar. Nowadays, it's SUV. And sedans is actually quite small and getting smaller. I've seen some of the vehicle makers not even having any sedans whatsoever. I think Ford just nixed out having all of their sedans. They took away their last one. All right, which type of vehicle has the least? Well, in this case, it'd be truck. Okay, now, what does the section labeled with section 5 represent? So, careful on how you word this. This is the proportion of trucks that are made in the United States. Proportion of all trucks. So it's the x-axis is the proportion of, or this height here is the proportion of the trucks that are made in the United States. So that's a big deal, making sure you get that correct. Of the trucks is the denominator. Okay, the section number 6. Again, make sure you get the denominator correct. Proportion of the SUVs that are made in Asia. Proportion of the SUVs that are made in Asia. And so there's that. And finally, what do the values of the x-axis represent? So let's talk the generic x-axis and y-axis statement. So for the x-axis, that is your overall, your marginal distribution of vehicles. And so I want you to think, in terms of all cars sampled. Okay, so all cars sampled is for the x-axis. All cars sampled is the denominator, and SUV, sedan, sports, truck, wagon are the numerator. So it's going to be the proportion of all cars sampled that are SUV, sedan, sports, trucks, and wagons. Okay, so here I have that, the proportion of all vehicles sampled that are, here's your numerator. Now, let's take a look at how we define what's happening on the y-axis. So here is this right here. I want you to think of the y-axis in terms of this is the numerator and this down here is the denominator. So we would say the proportion of all types of these types of cars, proportion of each car type, that are made in USA, Europe, and Asia. The proportion of all car types, these car types that are made in, I should have said that, USA, whatever the 3 different ones are, USA and Europe and Asia. Okay, so there is how you do that. There does do the type of vehicle and origin appear to be independent? No, definitely there's different heights of the bars indicate that there's definitely something going on. The fact that you are from a particular country changes the rate at which you are it made that type of vehicle. Okay, So that is going over the mosaic plot and how to correctly word all of those different things. So I hope that helps, and good luck on your quiz.